Hi, I'm Paul Peterson.
Hi, I'm Leslie Finger. Paul, what is an experimental study? What other names do we use to refer to experimental studies?
Well, experimental studies go by a lot of different names. You can call them a randomized experiment, a randomized field trial, a randomized clinical trial, the gold standard in research. All of these things are pretty much the same thing as an experiment. The essential core idea is that you randomly assign people to a test group or a treatment group and to a control group. And only the luck of the draw decides whether you get to go into the treatment group or into the control group.
Okay, but what exactly is an experiment?
Well, the purpose of an experiment is to try to understand what happens both in the presence of the test and in the absence of the test. A counterfactual, you always have to have a counterfactual. You have to have something against which you are comparing the test. And the counterfactual is what would have happened if the treatment had not taken place. So, for example, if you take a piece of wood and split it in half, and one half of it's on fire, and the other half is sitting over there as simple as can be, then you're knowing that fire causes wood to burn. So that's what you would like to do in research on human beings as well, except you can't, for any person in the world, ever give them a treatment and not give them a treatment at the same time. That's totally impossible. So what we do is we try to get as close to this as possible by splitting groups into control groups and treatment groups and assign people to those groups randomly.
What do we mean when we say treatment?
Treatment, well, treatment can be anything. Anything that is asking the people in the treatment group to do something that the control group is not asked to do. The control group can do something just as usual. They go on with life as usual. Sometimes in medical research, we give the control group a placebo and the treatment group a pill. So the classic example of treatment is somebody gets a pill and somebody else gets a placebo. In education, you can't do that because everybody knows whether or not they've been put in a small class or a big class. And so you do the best you can in terms of setting up a situation where the control group is exactly like the treatment group, except in this one respect.
But I don't get it. What is the control group? What do they get? What's given to them?
Well, they may get nothing, or sometimes they'll get the opposite treatment. That is to say, in some kinds of studies, they will say, okay, this person's going to get a pill, that person's going to be given a psychological counseling. So it may be the opposite or something quite different from the treatment itself. So a control group can be business as usual. It can be a placebo, like something that looks like a pill when it's not a pill, or it can be a different kind of treatment.
Does an experiment always need a control group?
Absolutely. Without a control group, you don't have an experiment. This is one of the biggest mistakes that's made by ordinary people when they say, does something work? Because they want to say, oh, did things improve? Well, the only answer you can ever give is, did it improve compared to what would have happened otherwise? And if you don't know what would have happened otherwise, and the only way to do that is through a control group, then you do not know whether or not something worked.
But why are experiments called the gold standard of research?
Well, because of this idea of random assignment, you can assume that the two groups are exactly the same, except for the fact that one was lucky or unlucky enough to end up in the treatment group. So, yeah, it's the random assignment that makes the experimental research design the gold standard, something which scholars would always like to have if they could get it.
I've heard people say that experiments have really good internal validity. What does that mean? What does internal validity mean?
Internal validity is the simple idea that does this actually prove that the experiment worked or that the treatment worked? So if you have random assignment to the treatment group and the control group, and you did all the other things the right way, then with an experiment, you can be pretty confident that what you got really tells you what happened, that whether or not, in fact, the intervention had the effect that was intended.
Okay, so it seems like experiments are really great for finding out if something worked, because they have great internal validity. But then what are the problems with experiments?
The biggest problem is external validity. External validity is trying to extrapolate from this small group of people that you studied to the larger population. And most experiments are done on small groups of people. And oftentimes these people who agree to participate in an experiment are unusual people. In medicine, they used to conduct a lot of the medical experiments on nurses because they were nice and available in the hospital, and they were very compliant. But that did raise questions about whether or not the findings would apply to other people who weren't nicely available and weren't compliant and may have bad habits. So can you take people who have good habits and say that the pill works for them and apply that to other people who may not have such good habits? So that's the biggest problem you run into with experiments.
Can you give me a couple of education examples?
Well, for example, in desegregation research, experiments have been done in particular cities at certain points in time, and often they find that they don't find benefits from desegregation. But these results are usually done in situations that are very unusual, so we don't know if you can generalize from them. Or in charter schools, a lottery may decide whether a student is admitted, and that allows for an experiment. But when you have lotteries, that means these are very popular schools. So would the results hold for other charter schools that are less popular? So these studies may have internal validity, but we're not so sure about their external validity. In short, experiments are generally applauded for their internal validity, but critics often question their external validity. Still, internal validity is the most important thing, and that's why experiments are thought to be the gold standard.
I've heard the term quasi-experiments. What are they? What are quasi-experiments?
Well, they're a very popular kind of research these days because they like to find natural experiments in the real world, situations that are almost exactly like the true field experiment. There are various kinds of quasi-experiments, but the essential element is identifying in the real world situations that seem to have automatically, naturally, produced something that resembles an experiment.
Okay, but can you give me an example?
As part of the Clean Air Act of 1970, the federal government said some parts of the United States had dirty air and they must clean up their air pollution, but other parts of the country had clean air, so they didn't have to do this. To make the law work, the government set a particular level that decided which parts of the United States had to comply with the law. And so there were some counties in the United States that barely missed being identified as dirty, even though their air wasn't much different in quality from other places that were said to be dirty. So here you have two sets of counties. One set of counties said to be clean, other set of counties said to be dirty, just because they were on one side or another of a cliff. That is, this little policy decision that was setting a particular number that decided whether you were dirty or clean. And so this cliff, or this cusp, is the mechanism that produces something similar to an experimental condition. Now, the economists who took advantage of this wanted to find out whether or not you had a reduction in infant mortality if you cleaned up your air. So he compares the counties that fell off the cliff, the ones that were said to have the dirty air, with the ones that stayed on the cliff, the ones that were not much different but were said to have clean air. And he found that there was a reduction in infant mortality if air pollution was reduced. So in this case, it was a good thing to fall off the cliff.
Okay, but that sounds a lot like an experiment.
Well, it is, but it's not exactly the same thing because these counties were not randomly assigned to the test and the control condition. There's some chance that the two groups of counties would have been different in some way that we don't know, and that accounts for why infant mortality rates went down. So in the absence of random assignment, you're never absolutely sure.
Okay, but if that's true, that the groups aren't necessarily the same, why are quasi-experiments so popular?
Well, they're easy to do. And the second thing is that they're real life situations where sometimes experiments are sort of conjured up and they're at risk of being something in a laboratory and not in the real world. But the best reason for doing it is because lots of people with clever minds can figure out cliffs and cusps that might tell us something with a minimum amount of research time and energy, whereas conducting an experiment is a major undertaking.
So would you say there are any cliffs or cusps in education?
The best example is a merit pay increase in Washington, D.C., where the government decided to pay teachers an extra bonus if they were found to be excellent teachers 2 years in a row. At the end of the first year, some teachers are found to be excellent and other teachers were not. But it was just a cliff that distinguished between the two groups of teachers. So one group of teachers had the chance of becoming a well-paid teacher, and the other set of teachers did not have that chance, and yet their scores were very close. So by comparing these two groups of teachers on the cliff, they were able to find out whether the opportunity to earn a substantial salary increase would really motivate teachers to higher levels of performance, and it did.
Let's now turn back to Josh Goodman, who will explain to us why he uses quasi-experiments in most of his research.
So now what I would like to ask you about is something that is very much a part of research, but not so much a part of everyday life, and that is experimental research. Experiments or randomized trials. These things that we do, and a lot of people know about it in medicine, so why do they always insist on checking out a new pill with a randomized trial?
Well, I think the issue is that you always want to make sure that the people you're comparing in your study start out looking similar to each other. A big question, for example, in education research is the effect of class size on student outcomes. And there's a funny result you get, which is it actually looks like in our data that kids in bigger classes have better test scores than kids in smaller classes. So at first you think, that's very strange, something's got to be wrong. It turns out that there is something a little bit wrong, which is that kids who are a little bit better behaved and doing better to begin with tend to be put in larger sized classrooms because the teachers know that they can teach them in that setting. Whereas kids who are maybe not well behaved or are struggling are often placed in smaller classrooms. And so if all you were doing was a comparison of these two groups of kids, you'd get potentially the wrong result, which is it looks like the big classes are good for kids, when in fact those kids started out different to begin with.
So how does the experiment solve the problem?
So experiments solve the problem because if the researcher is allowed to run an experiment, it means that he or she is allowed to create two groups of students that look identical to begin with, but one of them, for example, is put in a large classroom and the other in a small classroom.
Well, how do they do that?
So the way they do that is usually they take a list of the students that are going to be part of the experiment and either flip a coin or more likely put them into a spreadsheet and tell the spreadsheet to randomly sort the students in some order. And then the students who end up at the top end up in, let's say, the small classrooms, and the students at the bottom end up in the larger classrooms.
So it's like gambling.
It's a lot like gambling, and there are always ethical concerns about experimenting on students. And so, the reason the researchers want to do this is because we think these experiments actually have great value for learning what works in education.
But now some people do what are called quasi-experiments. How does a quasi-experiment differ from a real experiment such as you just described?
So I actually am a researcher that studies only quasi-experiments. I don't do randomized experiments. And the reason I use these is that there are lots of situations in life where we either cannot run an experiment, we're not allowed to, it's potentially too expensive, or we're trying to study something that takes so long to happen that an experiment wouldn't yield results for 10 years. And so quasi-experiments are ways of using changes in government policy or other aspects of the world that are already happening to mimic a randomized experiment, basically
How
to
do you
fake an
mimic it?
experiment.
How do you fake it?
So I'll give you an example. Here in Massachusetts, there's a merit scholarship program that I've studied called the Adams Scholarship. And kids who win this scholarship are those who get a very high score on the state's high-stakes standardized exam. And if we wanted to know whether this scholarship changes kids' decisions about whether to go to college or where to go to college, the problem is that all the winners are scoring higher than the kids who don't win it. And so those two groups of kids are very different to begin with. So what I did in a study on this was to compare the kids who were just on the threshold of winning the scholarship, the ones who just barely got enough points in the exam to win, and the ones who just missed by one question winning the exam.
It sounds like gambling.
It's very much like gambling. If one of these kids had just sneezed, he would have lost his scholarship on the exam. And so these two groups of kids are very, very similar. They have nearly identical scores and other characteristics, but one set got the scholarship and the other didn't. And so we can track these kids over time and see what happens to them.
So a quasi-experiment is trying to find something in the real world that's just about exactly like an experiment. So should I believe these quasi-experiments? I suppose you believe I should.
You absolutely should believe them if they're well done. And you have as with randomized experiments, quasi-experiments have to be done carefully. And there are ways to check that they're being done properly. You can check that the two groups of kids you're comparing look similar to begin with. But if they're done well, I think we should trust them.